Hi everyone, and welcome to lesson 4 of the topic on building blocks. As with all the other lessons, you will need a pen and some paper. So if you do not have them in front of you, please go and find them now and pause the video. This last lesson on building blocks is on purity. And the challenge for today's lesson is to describe the difference between a pure and an impure substance, and the aspire is to explain what effects impurities have on a mixture. Okay, the starter for today's lesson is I would like you to write down what you think of when you hear the word pure and what does pure actually mean. Now, pure is a word that you would have heard quite often, and whether or not it has the same meaning in chemistry might be entirely different. So I'd like you to write down your thoughts. So what do you think of when you hear the word pure, and what does pure actually mean? Okay, I'm going to give you 2 minutes to write down your thoughts. Off you go. Okay guys, so the question that I asked you was, what do you think about when you hear the word pure? And then what you actually think the word pure means. Now, when I was growing up, and even now when I go to the supermarket, I see things like the word pure written on bottles of mineral water. I see it written on orange juice labels where it says pure orange juice. Now, in chemistry, a pure substance consists of only one element or one compound. There is nothing else there. So an example that I can give to you is pure water is just H2O, nothing else in it. So to make it clear now, the water that comes out of our taps that goes into our houses, that is not pure water because there isn't just H2O in that water. There are other things in there as well, dissolved minerals, dissolved salts. So when we use the word pure, even like with orange juice, if you look at a label of orange juice, you will see that on that label, if you look at the ingredients, there is not just one element or compound in there. In orange juice, there is many ingredients making up that orange juice. So therefore, we can't really label that as pure orange juice in terms of chemistry. So sometimes in everyday life, the meaning pure has a very different meaning than what it means in chemistry. Okay? So just to reiterate to you all, a pure substance in chemistry consists of one element or one compound only, nothing else added into it. So as I've just spoke to you about orange juice, you can see this label here from some orange juice from Asda is labelled as 100% pure orange juice. And the label that Asda is portraying is that this orange juice is just orange juice and it's got no other substances added in it. However, like I said to you earlier, the juice isn't pure in the chemical sense because there will be other things in it as well. So what this then means is that this pure orange juice is actually a mixture of different elements and compounds. So just a quick recap from lessons previous that we have done on building blocks. So I would like you to write down whether or not these diagrams are elements or compounds, and whether they are pure or they are mixtures. So I would like you to write down in your books 1 to 5. Okay, so please remember that something that is pure, remember, contains an element or a compound, nothing else in there. Okay, so I'd like you for each diagram to write down whether it's an element or a compound and whether it is pure or a mixture. Okay, so I'm going to give you 4 minutes to do this. Off you go. Okay guys, so now I'd like you to self-assess your answers, so please get a different coloured pen to mark your work. Just a quick recap from the previous lessons on building blocks. So remember, an element consists of one type of atom, and a compound would be two or more elements that are chemically joined or bonded together. So number one you should have had is oxygen. And because there is just oxygen there, the element oxygen, and nothing else is in it, it is a pure element. Okay. Number two, you can see that there are two different types of atoms making up that compound, and that is carbon dioxide. So there is one atom of carbon and two atoms of oxygen, and it is pure because there is just carbon dioxide in there and nothing else is added. Number three, that is oxygen and helium. So remember that they are both elements because they contain only one type of atom each, and it is a mixture because there is more than one element in there. So remember, a pure substance is just one element or one compound, nothing else added in. The next one is a mixture of compounds. So if you look at the diagram, you can see that there are two different compounds in there, and you know it's a compound because there is two different coloured atoms. For the water and the alcohol, there is three different types of atoms there, and it is a mixture because there is more than one element or compound in that mixture. Then the final one is air. Now, air is again a mixture of elements and compounds, and if you look at the particle diagram, you can see that in there is different elements, and you can see the elements. The red ones is oxygen, and the blue ones will be nitrogen, and they are elements because they are just made up of one type of atom, it's one colour. And then there are also in there some compounds as well, and you can see that where there is different coloured atoms that are chemically joined, bonded together. So you can see examples there of carbon dioxide and water as well. So that is a mixture, remember, and it's not a pure substance because obviously there is a mixture there of elements and compounds. So if you could see the particles in pure water, it is just H2O. So pure water is a pure compound, just H2O. So you would only see those water molecules there. There would be no other particles at all in that water. However, most water, like I said earlier, water that also comes from your taps, that goes into your houses, it will contain lots of different things, such as dissolved gases from the air. There will be impurities in there, such as dissolved minerals. There will be microorganisms in there, and this will affect its properties. So what I mean by that, by affecting a property, is that it will maybe affect its boiling point and change it slightly. So you all know that pure water boils at 100 degrees C, so 100 degrees Celsius. Now, water that isn't pure, its boiling point will be slightly altered. So the more impurities that's in there, it will alter the boiling point more and more as more and more impurities are added into it. And usually if you boil a kettle, the water that comes out your tap, it boils around about 94, 95, 96 degrees C, and not at 100 like we expect, and that is because there are impurities in tap water. Okay, so now what I would like you to do is I would like you to draw me two diagrams. I would like you to draw me one representing pure water, and then the second one to represent mineral or tap water. And I would like you to label the water particles and any other particles that would be in the mixture. So I'm going to give you 2 minutes to do this. Off you go. Okay guys, so now I'd like you to mark your work. So hopefully your particle diagram of pure water looks like the one on the left. So it is just water molecules and nothing else added in there. You could have also drawn the water molecule like you've seen on the other diagrams, where basically it is a round circle with two other little circles stuck to it in a different colour, a bit like Mickey Mouse ears. So you could have that for pure water. So that is water. Pure water is just water, nothing else added in it. And then the mineral water is obviously water and other impurities in there. And it could have been salts, it could have been microbes, dissolved gases, whichever you would have labelled them as. So there are the two diagrams. Right, so now I'd like to do a little recap with you, and these are terms that you would have come across earlier on in Year 7 and also in primary school. So I would like you to write down what you think is meant by melting point and boiling point, and what changes do you see when something melts and something boils. I'm going to give you 2 minutes to write down what you think. Off you go. Okay guys, so hopefully you have written down for what is meant by melting point. This is the temperature at which a solid changes into a liquid as it is heated. So think about an ice lolly melting in the sun. So you need heat energy to be able to change something from a solid to a liquid. And what is meant by boiling point? This is where it's the temperature at which the liquid changes into a gas. So if you think about boiling a kettle or boiling a pan of hot water, you actually see then the steam coming off of it, and that is when obviously the liquid is changed to a gas at a certain temperature. So let's talk in a little bit more detail about melting points and boiling points. So as I said earlier, pure substances have a sharp or specific melting point. So I mentioned to you earlier about the fact that pure water boils at 100 degrees. So that is just water, H2O, nothing else in it. Now in pure compounds, we find then have a range of melting and boiling points. And that is because all of the different substances that they contain will melt or boil at different temperatures. And it even gets to the point where they may also interfere with each other's melting points, and so therefore it's altered. So I spoke to you earlier as well about tap water, and I said to you there's impurities in there, so that then reduces the boiling point of pure water slightly to around about 94, 95, 96 degrees C. Okay, so if we are to test for a pure substance, what we can do is go onto the internet and type in Google a specific substance, and it will tell you the melting point or boiling point of that substance, so what we should expect to get. And then therefore if we then test it and it's different, it obviously shows that this compound or element may have some impurities in it. So here we have a table, A, B, C, D substances and their melting points. And I would like you, for me, on a sheet of paper, to write down which substances, A, B, C or D, you think is impure. And I would like you to write why it's impure. Okay, so I'm going to give you 2 minutes to do this task. Off you go. Okay guys, so hopefully you have identified that substance B and D are impure, and this is because they do not have a set melting point. So they have a broad range of melting points. One is between 97 and 99 degrees C, and one is between 102 and 104 degrees C. Obviously A and C have sharp melting points. They are a specific temperature, so they are pure substances. Okay, so a quick little task for you now. You have made some sucrose from sugarcane and you would like to check that it is pure so you can sell it. So you know from data that the sugar has a melting point of 186 degrees C. When you melt the sugar, it actually melts at 179 degrees C. What does this tell you about your sugar? So I'm going to give you a minute to think and write down your ideas. Off you go. So hopefully, guys, you have written down that it is an impure substance, and it is an impure substance because it should have melted at 186 degrees C, but it melted at 179. So it shows that there is impurities present in your sugar. Okay, so next one is you have created aspirin and you need to check that it's a pure substance. You know from the data that aspirin has a melting point of 136 degrees C, and when you melt your aspirin you have a range of melting points from 128 to 137. Is your aspirin pure and why? So I'm going to give you a minute to write down your answer. Off you go. Okay, so hopefully, guys, you have written down that aspirin isn't pure, it is an impure substance, and it's an impure substance because we would expect pure aspirin to melt at 136 degrees C, but this aspirin that you've made actually melts between 128 and 137, showing that it's got a broad range of melting points, so therefore it's an impure substance. Okay, so that is the end of today's lesson, Year 7, and what I would like you to do for me now is I'm going to give you 5 minutes to copy down a summary of today's lesson. So the summary is a pure substance contains one element or one compound, nothing else added in it. A mixture consists of two or more different substances, not chemically joined together. Melting point is the temperature at which a solid changes into a liquid as it is heated. And a boiling point is the temperature at which a liquid changes into a gas as it's heated. Pure substances have sharp, specific melting points, and impure substances have a range of melting points and boiling points. So I'm going to give you 5 minutes to copy down this information. Off you go.